This is another video in our series on 5 random GCSE questions. Okay, so let's make a start. The first one of these is about linear inequalities on a graph. We've got 3 inequalities that define the shaded region. So first of all, note that they're all solid lines and not dotted lines. So that means it's including. And what we're going to do is work out what the 3 lines are that define the area. Well, we've got the baseline, which is the line y equals -2. Okay, and the region shaded is bigger than -2. So y greater than or including -2. That's the first one. The second one is we have here the line y equals x. Okay, that's the line y equals x. And the shading is above that line. So the second inequality is that y is greater than or equal to x. And the third inequality is this line here. And this line is the line y equals a half x plus 1. Okay, and the shaded region is below it. So it's y less than or equal to a half x plus 1. Okay, and that's it. Second question. This is a question about using the area rule for a triangle. Okay, a half AB sine C. And in this case, we've got the area given to us, and we've got to find what x is. All right, so our opening statement is that a half times the 2 lengths that we know, that's x plus 3 times 2x minus 1, multiplied by the sine of the angle between them, okay, is equal to the area, and the area we're given as 6√2. Okay, now it looks quite complicated, but it simplifies quite well in a moment. So I'm going to double everything to get rid of the 2, and I'm also going to write the sine 45 as 1/√2. Okay, but this is a calculator paper, so you could easily find that for yourself. So I'm just going to first of all write it like that. So it's a half of x plus 3 times 2x minus 1 times 1/√2. Okay, and that's going to give me 6√2. Okay, now if we now multiply it by 2√2 to clear the fractions, we get x plus 3, okay, times 2x minus 1. Now, it's going to be, well, if I'm multiplying by 2√2, it's going to give me 12 times 2, which is 24. Okay, so I now need to expand the bracket, so I get 2x squared plus 6x minus 1x, so it's plus 5x minus 3. Okay, and that comes to 24. So to solve that, I need to subtract 24 from both sides to give me 2x squared plus 5x minus 27 equals 0. And now I need to solve it. Now there's a clue in the question, give your answer to 3 significant figures. So it's suggesting it won't factorize, and I need to use the quadratic formula, which I will do. So x equals minus b, so it's minus 5, plus or minus the square root of b squared. Okay, now b squared is 25, minus 4 times a, which is 2, times c, which is negative 27, Okay, so it's the square root of all of that all over 2 lots of a. Well, a is 2, so it's 4. Okay, now we need to simplify that square root, and that comes to x equals -5 plus or minus root 241. Okay, and that's all over 4. So that would give us 2 solutions, or 2 values for x. However, one of those won't work, and you'll notice in the question it says calculate the value of x. All right, so let's see what those 2 values are. From the calculator, we get x equals either -5.131, okay, or we get x equals 2.631, etc. Okay, so we can discount that answer because it's negative, we can accept that one because it's positive, and then we conclude, because the length would be negative, you see, if x was that, this length here would be less than 0. Okay, so we just need to say that x equals 2.63 meters. Okay, so this is in meters, not centimeters. 2.63 meters to 3 significant figures, which is what the question required. Okay, and that's the answer to that question. Next question. Okay, this is about completing the square. So what we do is we have to use that to find the minimum point of the curve. All right, so what we have to do is square x plus 5. Okay, now I'll just write that over here because we got to show all our working. So x plus 5 all squared would give us the x squared. It would also give us the 10x. Okay, but it will also give us something we don't want, which is plus 25. So what we need to do is we need to rewrite our expression for y as y equals the square of x plus 5, right, which is this thing here, minus the 25, okay, minus the 25, but it also requires us to add the 18 because that's still there as well. So this is our working out. And then we can simplify that to say it's the same as x plus 5 all squared, okay, minus 7. And the minimum point occurs when this value is here, is as low as it can possibly be. And when you square something, the smallest value it can be is 0, okay, because if it's negative, when you square it, it becomes a positive number. And the only way to make this bracket 0 is to set x to minus 5. So the minimum point occurs when x is minus 5. So minimum at x equals minus 5. Okay, so the minimum point is at the point minus 5 or negative 5, comma, negative 7. And that's how you use completing the square to find the coordinates of the minimum point of a quadratic. Okay, and next question. Okay, this question is about box plots, and they give us one box plot, and it shows the information about the heights in centimetres of a group of Year 7 girls. And we've got to fill this box plot in for the heights of a group of Year 11 girls. We're given some information, but we need to be careful what we're given and use it properly. So the least height is 154. Okay, so that's at the bottom of the whisker. Okay, so it's 154. You must get this in the right place. Okay, and that's just a short vertical line there. Okay, something like that. Okay, then we have the median is at 165. The lower quartile, let's do that next, is at 161. So 161 is here, and that's the lower quartile. That's down there. Okay, the bottom end of the box, the left-hand edge. Then we have the median, which is at 165, okay, which is here. Okay, and then we have the upper quartile. Now, they haven't actually given us the upper quartile. What they've done is they've given us the interquartile range, you see, and that's the difference between the lower quartile and the upper quartile. So if that's 7, right, this is at 161, then the upper quartile must be at 168, which is here. Okay, because the length of that box then is going to be 7. And then we have the range is 20. Well, if we started at 154, that means we must finish at 174, which is here. Okay, so you can see it's going to be a very small, narrow box, but it fits all the criteria given. So we just need to now put the horizontal lines in. Okay, so there to there, there to there, and we just need to do the top and bottom of the box. Okay, so you need to be very careful with plotting that. I'll just try and straighten that up. Okay, you need to be really careful when you're plotting these box plots that they are plotted exactly in the right place. There's no excuse for being even one little square out. Now compare the distribution of heights of the Year 7 girls with the distribution of the heights of the Year 11 girls. These questions typically carry 2 marks or 3 marks sometimes. And to guarantee the correct answer for this, you need to do 2 things. You need to compare the medians and you need to compare the interquartile ranges. Don't talk about the mean because you'll get no marks. Don't talk about the average. Don't talk about spread. Use those specific terms, and if you can calculate them numerically, that gives you a watertight answer. And this is what I would write down for that answer. Okay, the Year 7 median is 157.5. Okay, you can see that quite clearly. All right, and that's less than the Year 11 median, which is 165. The Year 7 interquartile range is 10.5. That's the difference between 165 and 154.5. Okay, that's 10.5, the length of that box. That's greater than the Year 11 interquartile range, which we know is just 7 from the table. Okay, so that would get you all the marks, and it doesn't take a lot to write down. Okay. And one more question, and this one is about the recapture method, right? So you've got an island full of snakes, and on Thursday Isabella catches and tags 170 snakes. These snakes are then released. On Sunday she catches 240 snakes and only 15 of them had been tagged. So in other words, when she recaptured them, 15 out of the 240 that she had caught were tagged. Okay, so the proportion or fraction of tagged snakes was 15 over 240. Okay, and that's equal to 1/16. So that means she must have tagged originally 1/16 of the snakes. So if she had tagged 170, then the total number of snakes must be 170 times 16. Okay, and that comes to 2,720 snakes. Okay, and that's how it works. So that's the answer to part A. And for part B, explain one assumption that you've made Well, this often comes up, and it's simply this, that when the snakes were tagged and released, they immediately, or not immediately, but over the next few minutes or hours, sort of mixed up again and randomly distributed themselves around the island. Okay, they didn't just sit there in the same place waiting to be caught again. All right, so something like this. After tagging, all the snakes randomly redistributed around the island. That's what I would say for part B. And that is the end of those 5 GCSE questions. Take care.